Hello my dear students, in this lecture we are going to see one previous year GATE numerical. This question was asked in GATE 2010 for 2 marks on power loss in case of sliding contact bearing. Now the question is very simple. Let us jump to the question. The question is, a lightly loaded full journal bearing. Here they have mentioned it is a journal bearing. Journal bearing is a sliding contact bearing. It is a sliding contact bearing. Then has journal diameter of 50 mm. Journal is nothing but a shaft, right? Journal is a portion of shaft inside bearing. Therefore, shaft diameter or journal diameter is given 50 mm, which is nothing but radius of shaft will be 25 mm. That is diameter divided by 2. Therefore, radius of shaft is equal to 25 into 10 to the power minus 3 meter in case of meter. Bush bore of 50.05 mm. Bush bore means diameter of bearing. Let us say diameter of bearing is given capital D, which is nothing but a bush diameter 50.05 mm, right? Therefore, radius will be equal to 50.05 divided by 2 mm. Therefore, in case of meter, it is 50 point. In case of meter, it will be 50.05 divided by 2 into 10 to the power minus 3 meter. This is radius of bearing or radius of bush, and length of bush is 20 mm. Length of bush is 20 mm means the portion of shaft inside bearing is for 20 mm, means length of journal or the length of shaft inside bearing is 20 mm. Therefore, length is equal to 20 into 10 to the power minus 3 meter. Then, if rotational speed of journal is 1200 rpm, rotational speed of journal, that is n, is equal to 1200 rpm, that is speed of shaft is 1200 rpm, and average viscosity of liquid is 0.03 pascal second. Viscosity of liquid mu is given here, mu is given 0.03 pascal second. The power loss in watt will be, and the question is to find power loss. What is the power loss in terms of watt? And they have provided 4 options, right? Now let us find this. Now here I am minimizing the question so that we will get space for the solution. Now my dear students, if I want to find power loss, first of all I have to find torque, and if I want to find torque, I have to find frictional force, and to find frictional force we have to find frictional shear stresses, right? Let us say there is a journal and rotating inside bearing. Let us say this is a bearing of diameter D. Inside this bearing, journal is rotating of diameter D, and this journal is for length L, and the space between them is filled with lubricant. This space is filled with lubricant, right? Now let us consider this journal is rotating with angular velocity omega. Therefore, this point will move with velocity, that is velocity of shaft, right? And bearing is stationary, that is velocity of bearing is 0, right? And space between them, this is called radial clearance. This space is called radial clearance, and there is a linear velocity distribution. This is our assumption, right? Now let us find these values. Now we have to find first of all angular velocity of shaft, which is nothing but 2 pi n upon 60. Therefore, angular velocity of shaft is nothing but 2 pi into 1200 divided by 60. It is in rad per second. Then we have to find velocity of shaft, which is nothing but radius of shaft into angular velocity of shaft, right? Which is nothing but equal to velocity of shaft is equal to radius of shaft is given 25 into 10 to the power minus 3 in terms of meter, and angular velocity is 2 pi into 1200 divided by 60. Now let us solve for this velocity of shaft. You will find 3.14. This answer you will get 3.14 meter per second. That is velocity of shaft, and velocity of bearing is 0. Therefore, change in velocity is nothing but velocity of shaft minus velocity of bearing, which is nothing but velocity of shaft, which is nothing but 3.14 meter per second. Again, the space between them is called dy, which is nothing but radial clearance, which is nothing but radius of bearing minus radius of shaft, right? Therefore, it is equal to if I find this radius of bearing is nothing but 50, radius of bearing is nothing but 50.05 divided by 2, and radius of shaft is 25 into 10 to the power minus 3 in terms of meter, right? This is a clearance between them, which is called dy. Therefore the shear stress between them at layer will be equal to mu du by dy, which is nothing but mu is nothing but 0.03 into du is vs divided by cr, which is equal to 0.03 into 3.14 divided by 50.05 divided by 2 minus 25 into 10 to the power minus 3. Now let us find these shear stresses between the layers. If I find this, I will get shear stress equal to 3768 Newton per meter square. This will be the frictional shear stress. And once the frictional shear stress is calculated, let us find frictional force. Now the frictional force will be acting on shaft because shaft is rotating, right? Therefore let us find this frictional force. Now the frictional force is nothing but Fr, which is nothing but equal to frictional shear stress into area. Now area is nothing but the shaft is rotating or journal is rotating inside bearing, and the contacting area is this circumference for length L, diameter of shaft, circumference for length L, right? Therefore this frictional force will be equal to shear stress into pi dl. Therefore frictional force is equal to 3768 into pi into diameter of shaft is 50 into 10 to the power minus 3 into length of journal is 20 into 10 to the power minus 3. Therefore this frictional force you will find equal to 11.83 Newton. This will be frictional force. Therefore there will be a frictional torque, which is nothing but a frictional force into radius of shaft, which is equal to 11.83 into radius of shaft is 25 into 10 to the power minus 3, right? Therefore this frictional torque you will find 0.2953 Newton meter. Now question is to find power loss. Therefore power loss is nothing but torque into omega, which is nothing but 2 pi nt upon 60, that already we have seen. N is rpm, revolution per minute, torque in Newton meter, then power you will get in watt, right? Therefore put the values. Therefore power is equal to 2 pi n, n is given, rpm is given 1200 into torque is calculated 0.2953 divided by 60. Now let us solve for power loss, right? Then if I solve this for power loss, then answer you will get P is equal to power loss is equal to 37.1 watt. Now my dear students, go to the options. Option A will find correct choice. The nearest option is option A, that is 37 watt, right? Therefore option A is the correct choice. Thank you dear students. In next lecture we will see one more numerical on sliding contact bearing.